Hello and greetings to Dr. Said. Today we will be presenting our lab project for the subject KT24403 operating system. So the topic for our lab project is the reader writer's problem of trees with log and semaphores. So this is a classic synchronization issue in current programming where multiple trees needs to access a shared resource. So before we continue the presentation of our project, let me introduce the member of our group. I'm the first presenter, Nur Afifah binti Abdul Rasid, and there's my friends. Second presenter, Zal Hazmi bin Husaini, and our other group member is Kalinia Meka, Siti Nur Fatina binti Masrom, and Wan Hairul Azmi bin Awang Ibrahim. Okay, next slide. We jump to the reader writer problem, or which is what is the reader writer problem. So the reader writer problem involves ensuring that multiple readers can read a shared resources simultaneously, but only one writer can write to it any given time. So our objective is to develop and implement an algorithm using trees, logs, and semaphores to manage the synchronization issue. Next. Okay. The key condition that we need to ensure are multiple readers can access and read the file simultaneously. Only one writer can write to the file at a time. And then writers are prohibited from writing when readers are currently reading the file. Here are visual representation of the condition for the next. To address this challenge, we established 4 key conditions for synchronization. Okay, the first one, multiple readers can access the shared file simultaneously without interface. The second one, only one writer can access the file at a time, ensuring exclusive access. The third one, readers must wait until the writer has finished writing before they can access the file. And the last one, the writer must wait until all readers have finished reading before they can write to the file. Move to our next slide. In our methodology, we use street logs and semaphores to implement the solution. So the synchronization was ensuring using mutex loop to prevent simultaneous writing and reading. The condition variables to manage the waiting condition. We wrote function for reader and writer to handle their access to the shared resources. So in the slide, showing the condition that we established. The first one for control variables and the second one for function. For the control variables, we use 3 mutex semaphores to ensure mutual exclusion when updating read count. And the second one, write mutex, that is a mutual exclusion log for writers. And the last one is the read count, which is to keep track of how many processes are currently reading. Next, the function, we have 5, which is a wait for actually we use a wait, signal, read, write, and check. Okay, move on. Next slide. I'll pass the information section to our second presenter.
Right. So for the use of semaphores and mutexes, there are SEMT read count SEM. It's a semaphore for read count synchronization. Pthread mutex T, write mutex, is mutex to control writer access. Pthread mutex T mutex is for general mutex for critical sections. And pthread condition TCV is condition variable for signaling threads. For global variables, therefore, for the read count, is an integer read count, is a counter for the number of active readers. Integer is writing is flagged to indicate if writing is in progress. Integer active readers is an array to track active readers' IDs. Integer active writer is variable to track the active writer ID. And integer writer queue is queue to manage waiting writers. And lastly, integer queue length is length of the writer queue. And this is all of the functions that wait, signal, check, read, and write. And this is signal and wait functions. In wait function, which is wait bit thread mutex t mutex. The function is to lock a mutex, and for the signal is to unlock a mutex. And then for check functions, the check functions prints the current status of readers and writers, including any writers waiting in the queue. For the read functions, it handles the reading process for a reader. The read functions will check if the reader is already reading, handles reading when no writer is writing, simulates reading with a sleep duration, check if the reader has finished reading, and update the status accordingly. For the write functions, it handles the writing process for a writer. If the writer, it can check if the writer is already in the queue, manage writing if no readers or other writers are active, adds the writer to the queue if necessary, and there are another function is in queue, which helper functions to check if a writer is already in the queue. And this is the thread functions. The read the threads functions for readers and call read functions. And for the writer thread, the thread function for writers to call write function. And this is synchronization functions, which is wait, pthread mutex tmutex. The function is to lock a mutex. And signal pthread mutex tmutex. The function is to unlock a mutex. And then this is the menu functions. It handles user input and manage reader and writer threads. And provide options to add readers or writers. It allows users to print the summary or exit the program. And for the print summary, it prints a summary of active readers and writers. And for the main function, it calls the menu function to start the program. Now let's look at a demonstration of our program. Here are screenshots showing the program in actions with readers and writers accessing the shared file. Notice how synchronization ensures proper access control. This is the scenarios of reader when writer writing. And sorry, we can see that there are there are writer one already in the queue and the writer one is writing. And the scenarios of reader when no writer is writing. They are allowed to read and we can choose if they've already finished reading or not. And this is the scenarios of writer when no writer is writing and no reader is reading. So the writer already in the queue and they can write. This is the scenario of writer when writer writing and no reader reading. Yes. And then this scenario of writer when no writer writing but reader reading. They cannot write because they are reader that's still reading. This scenario of summary, we can see the summary of the reader and the writer, which writer is reading, which writer is writing, and which reader is reading. And this is the scenario of exit, which is choice number 3. And then this error handling, which is invalid choice input. Let just like enter. There are no 5 can for the choice, so it will say invalid choice. Please try again. And this is also another error handling, trying to add the same writer to the queue multiple times. It will show that writer is already in the queue and cannot add it to the same writer twice. And this is another error handling. Try to add a writer while a reader is reading. It shows that the reader cannot read since another writer is still writing. So in conclusion, we effectively solve the reader-writer's problem using threads, locks, and semaphores. Our solution allows multiple readers to read simultaneously while ensuring that writers have exclusive access. This project highlights the critical role of synchronization in concurrent programming.
Okay, we also achieve the primary goals by implementing a synchronization technique that prevent reading during writing and writing during reading. So extensive testing confirmed the reliability that and accuracy of our approach in managing concurrent access to a shared resource. So that's all from us. Next slide. That's all
Thank
from
you.
us. Thank you.